Our new ultra-thin platform, so you may have heard of it. If you've never seen it before, you can come and play with it. This is the DV2. So those of you who have netbooks and those of you who have notebooks, you're probably discussing why did one of you have a netbook and one of you have a notebook. Would it be nice in a netbook type of weight and size to have a true notebook experience? And you can buy an Apple Air if you have $3,000, or you can buy one of these from HP for $699. So this is the brand new lightweight DV2, and so we'll leave it up front. You can come and play with it. Patrick's the minder from it. It's not actually available in bulk till April, so if I will split the money with you if you let me take it away. What's interesting about that, it really solves some of the compromises we've all been living with between the notebooks and the netbooks in terms of performance and power. So that was the first big thing we did. The second big thing we did was we announced our new Dragon platform. So the Dragon platform, if you guys remember, we did Spider. We announced Spider as our new desktop platform. Then we decided to keep it secret and not talk about it anymore, as if we were somewhat embarrassed about it. And part of the reason we did that is because people like you said, it's a great idea, but the processor suck, the graphics suck, and the chipset suck. So in the last year, we
great
sort of...
name, though.
Great name. And the image looked lovely, you got to get that. So in the last year, what we've been doing is really replacing the chipset with the 790G, which is now a great chipset. We've been replacing the graphics with the 48 series, 4800, and we'll give you can get an X2, which is the best graphics card in the planet. What it's really needed is some kick-ass processors. So today we announced the Phenom II, which filled in the gap, and there's an overclocking thing going on tomorrow if you find it. I believe the fastest this thing's been overclocked to is now
6.3.
Okay, with liquid nitrogen. So may not be for your kitchen at home, but on air it's up to about 3.7. And what's fun about that is, in the same way that the DV2s, how do I not compromise on the performance but get at a proper price? We think you can build one of the best gaming rigs for a PC, which you would have paid over $1,600 for yesterday. Today, you're going to pay under $1,000. If you don't believe me, go to Alien, go to Dell, look at their new XPS. It's a quad-core, dual X2, 16 or 32 gigabytes of storage. It's the fastest gaming machine probably on the planet at this point, and it's $999. So in these tight, sensitive times, that's pretty good. But that's not really, that's all about today and the products. What we want to talk to you is a bit about what the future looks like. And in particular, if this thought that the processor doesn't gate the performance of the platform, what we're really talking about is once you bring graphics and all the rest of it, what can that look like? And I'm not saying processor's not important, don't get me wrong. It's just we believe one part of it. So Jules, today we announced the Fusion Render, what do we call it, node?
Fusion Render.
Fusion Render Cloud. So one of the things about cloud computing is, it's been really good for your email, it's been pretty good for doing a few spreadsheets, but you couldn't actually use it for maybe delivering high definition pictures to a web browser on your iPhone. And that's what we demonstrated today in our CEO's keynote. And what Jules, and we'll let Jules talk a bit about what they're going to do, is we've said that we will put within about a year a petaflop of graphics processing available in this render node. And you can buy a petaflop worth of computing today, but you'll pay 10 times the amount, it'll use 10 times the power, and it'll take 10 times the space. We're going to do that by combining 1,000 graphics cards together and doing high definition rendering. And that's a pretty set of interesting things you can talk to Jules about. So, we do think it's about the experience. We do think it's about more than just the speed of the processor. It's about the graphics and the chipset. But we thought much of our marketing on this stuff is around see for yourself. So we thought it'd be fun to show you what this looks like. So Eric, if you want to come up and spend a couple of minutes on Image Metrics. I'm going to show you when you start using and Eric and also Mike, the CEO, they're going to show you when you start to really use our graphics cards to do real work, what you can get. And on this demo, the processor is pretty non-busy in this, isn't it?
Yes, it's pretty non-busy. It's using pretty much the graphics processor for what we're about to show you.
And this is my favorite part. So guys, you go do the story, And everybody, it's time for you to meet Emily if you've not met her before.
So thanks for paying attention to this stuff. We are Image Metrics. We've been in business about 6 years. Primarily what we do is image analysis. So we started out as a bunch of PhDs in Manchester, England, who were looking at ways that pictures move. And we actually have some mathematical methods for extracting movement in moving pictures. And we've done a bunch of different things with it. We have some medical stuff and some security stuff, but the thing that the business is really focused on for the last couple of years has been the entertainment business. And so we've been actually doing a lot of stuff with taking facial movement and putting it onto digital characters, primarily in video games and in films. So it turns out that's a really hard problem, that movement and animation of a body is actually kind of a solved problem. You can do it by hand pretty easily by moving it around in a 3D program. You can do it using motion capture. But when you go to try and get the face, all of a sudden you encounter a completely different problem. And that problem is that the subtlety and the meaning that comes out when your face moves around is much, much harder. If I happen to move my hand that way instead of that way, you might not take much home from it. But if I frown wrong, you just lose all intimacy with that character. So I wanted to give you a sense of some of the stuff we've done. You can kind of roll this one. So this is Grand Theft Auto 4. We did all the faces in this. This was 300 minutes of animation. And this is a pretty good example of what goes on in this current level of consoles. And it underlines kind of one of the problems we have, which is the console software and the processing power is always in contention. This, if anyone was sitting in that back room there, somebody was playing Gears of War 2, this was a promo done in-engine for the VGA Awards. So that's the same assets, but to get this level of facial reality right here, it's really, really difficult to do by hand because you have to move everything in synchronicity. Everything has to be believable. This is a video done by Gnarls Barkley, and we actually did the lips here, which, if any of you are Gnarls Barkley fans, actually look like the lips of the guy who sings for them. And this is an internal demo where we're just showing how we can actually, I just wanted you to see that there's no markers, or we just took a picture of somebody and we put it onto a digital character in very, very realistic form. So, two businesses that we're in then, the games business and the film business. And in the film business, people are into creating more and more realistic versions of this. And it turns out that the more and more realistic you try and make this, the harder it is for an animator to get the subtleties of the face right. So in Grand Theft Auto, where the resolution is game resolution, there are great animators out there who can do it. They don't need technology. I mean, there aren't many, but there are some who can just do it. But if you try to get into a situation where you're doing something photoreal, right? So you just get to the point where it's so difficult for an animator to get it right that the technology becomes very, very useful. So for example, I don't know if anyone here has seen the Curious Case of Benjamin Button's movie that just released. Okay, so our technology was used to take the performance of Brad Pitt and put it on the performance of Brad Pitt, but 20, 30 years older, right? So we were, if you have a chance to see that movie, if you see it again, that is kind of that is the penultimate, at this point, example of photoreal. I mean, most people walked out of that movie saying, gosh, I guess that was great makeup. But aging is a subtractive process, not an additive process. So if you were doing makeup, it wouldn't look quite right. So as an example of prior to, Buttons just came out. Prior to that, we were actually working on some other stuff, and we were at SIGGRAPH, which is a show that was in LA in August, and we presented this, which is a woman named Emily O'Brien, who's an Emmy-nominated daytime TV actress. And we worked with Emily for a long time, taking photos of her and using her as sort of our face. And we've done a series of different things with her. So what she's doing, you can go ahead and roll it. Okay. What she's doing right here is just explaining us. So I'll talk right over it because it's not very interesting. I just told you what we did. But we just shot her in our offices like this, and then we took her facial image, and then using a light stage to actually scan her, we created a head that looked exactly like her. So what you're seeing here is actually not her. This entire video is fake. I mean, actually, to be completely fair, the face is fake, and you'll see which part we did a faceplate because we didn't want to actually. We're not in the hair business, right? We're not in the background business, and we're not. Yeah, she liked that one for Halloween. This is my favorite because it really shows the subtleties of the movements. And then that's actually her. The major difference, actually, if you were to, and by the way, if anyone wants to see it again, it's on YouTube. It got 1 million hits. It kind of was an interesting viral thing. And we actually have them on little sticks if you want to take it home with you. All these assets are available. But the thing that was most interesting about Emily was it was pre-rendered. It was the movie people, which is the real audience at SIGGRAPH, were fascinated, right? Okay, wow, we can really. And by the way, the actual animation piece of it for us was a nights and weekends project, right? We didn't. This wasn't something we got paid to do. We did this to push the limits of the technology. And one of the things that the industry thinks is interesting is how quickly we were able to actually do it. So then we said, well, it turns out that our business today, there's only a certain number of CG photoreal type movies out there. And so movies are a percentage of our business, but the lion's share of our business today is actually in the games business. And so when the games business looked at this, they say, that's fabulous. But how are you going to put that in a game? You pre-rendered that. You had months to get the head right and get the animation right and get the rendering right. And so I literally left that show after getting that feedback, and I went to my team and I said, you guys, we've got to be able to do this in real time. And the team looked at me and first of all, they said they were tired because they've been working really hard to get that. And at the end of it, they basically said, all right, well, here are the problems you have in trying to get this done in real time. The first problem is actually producing it, right? So producing the animation is so hard, people just sometimes don't do it. I mean, if you think about where faces are in video games right now, there are a lot of video games with masks on the characters, right? And an awful lot of video games where they shoot kind of over the back of the character, or they shoot long shots so you can't see the video. And so we actually solved that problem, right? We are at a point now where, and we've got several proof points, that we can actually make it so easy to do animating the face that we think that actually people will start using it more and in different ways, right? And that's actually kind of our mission. But there's two other things that have to happen for us to actually get this done. One is there's a software problem, right? So I can render this, right? But if I want to run this in a game engine, that game engine has to be capable of showing something at this level of quality, right? And so one of the things, anyone who saw the OTOY stuff earlier in the keynote or has any experience with it, that is a real-time rendering environment. That is, I mean, if you look at that environment, you feel like you're standing in that city, right? So now with something like that, that solves the problem for us of being able to render real-time a face in an environment where it looks like it's real, right? But then there's another problem, which is, you run into this hardware problem, where a face is contending with the background and the walls and the city and the movement, and you might want 5 faces on the screen. And so what games industry people generally say to me is, all right, show me the processor power that can do this. And that's how we came to know AMD. So I sent my guys away from SIGGRAPH, and they started working. They went back and worked with the LightStage guys, worked with the guys at the USC ICT Center who actually sort of founded the concept of some of these shaders and renderers. And what you're going to see today, this is the first time we've shown this one, but we've actually shown something similar before. But this is the pretty much cutting edge of what we were able to do with real time. So it's the same head that we did with photoreal SIGGRAPH, Emily, but we're actually going to render it on this machine in real time and move it around so you can see that it's being done. And by the way, it's a different act, right? We went back and took another picture of her saying something different and put it on here. So it's a little bright actually on this particular monitor, but that's just a vagary of the monitor. But what you're seeing here, so she's still, she's not moving, but she's being rendered in real time. Eric's moving the light around, and he can actually move the face around too if we get to that. And so she actually, if you pull the light away just enough so that you can get, I mean, where I'm standing, I can see pores, I can see shadows, I can see the real detail of her lips, which is one of the places where we actually add some benefit. Because if you think about doing it with markers, being able to track people with markers on the face, have you ever seen that? The little balls on the face? You can't put them on the lips, you can't put them on the tongue, you can't put them on the teeth, right? So go ahead and roll her.
Well, I really like to appear in real time so that we get the same quality.
There's a little audio sync problem in this one, but there's just little subtle movements around here and synchronization between her upper cheek and the sides of her mouth. And there's an interesting thing that everybody notices about Emily when I show this stuff, which is, hey guys, you screwed up the eyes. The right eye is different than the left eye, and she's got asymmetry in her mouth. And you know what? Her right eye is different than her left eye, and she's got asymmetry. I don't think she particularly appreciates when I point that out. That's part of my business. So this is an interesting thing going on, and we've started showing this to some people in our business, right? And when we show this to games people, they say the same thing that they said before, which is, nice stop, which is, hey, that's great, but how am I going to get 5 of those running? How am I going to get the background running? How am I going to, And the answer is, we checked it earlier, if I put Task Manager up on this thing, the CPU is completely dead. This is all being done on the GPU. And if I put the GPU tracker up there, we can run 2 or 3 of these at the same time on this machine. And that's the power of the AMD relationship, right? The AMDs, with Dragon, they've gotten a package where this kind of stuff is here. It's now. We can do it now. There are a bunch of applications. The game application is an obvious one, right? The next application that we're working on is real-time free visualization. So the idea that somebody can look at a capture they're doing for a movie and really see what the character is going to look like. So what, in our work on movies we've done before, they take a capture of the actor, and then we go back and we render it up, and then they see what it looks like on the character. And you might do 50 takes, right? And you have to pick a take, and you see only the one take that you picked on the actor. But with something like this, we could just render out all 50 takes right away. So you're really getting a better sense of what's going on. Another thing that happens in the film business is that the director wants to sit there and direct the action, right? So if you can actually look at, there's something really important to tell you about this. I didn't do it for this, and this is why he thinks it's scary, but I could drive Emily, right? A video of me could drive her movement.
You can show that? This is the answer to online dating.
Oh yeah, absolutely. Don't think that hasn't hit our radar. So why don't we kill this for now? I'm happy to show this closer up to people. I don't want you to
come and play with this later. So.
Yeah, I don't want you to think that by putting you 50 feet away from the screen, we're trying to doctor anything. I'm happy to play with this. It's here. But show the other one. So just pause it. Pause it for a second. We talk. So please, no comments on my acting. So what our technology does, just to remind you, is it takes the image, right, and it watches the movement in the image, and then it puts it on a digital character. That's not me. That's not intended to be me. That guy's much better looking than me, right? And so the idea is that there's no reason that couldn't be Emily, except that we really don't have Emily's permission for that, so we're very careful about that. This is a mock-up. This is actually a demo, and we don't have the actual the live stuff working on this particular setup right now, which is why we're doing a mock-up. So very clearly, this is a mock-up, but the quality's right. And this is about driving it live. So everything we've talked about so far is we package up the performance of whoever, and then we display it, and it's a canned performance. But the thing we're doing next is even more exciting. So that's a webcam. I'm sitting at a desk. I could be driving my Warcraft character. I could be driving a chat character. I could be driving, there's just Second Life, virtual worlds, right? And it works now. We have this working. The challenges to this were around processor time, right? Because we now have to do what this hard mathematical analysis we do. We have to do it in sub-frame rate. We have to do 30 times a second, which it turns out we can do. But we couldn't do it 4 years ago, right? It's something that where the processors are. And by the way, for most real applications, it has to be grabbing those frames, analyzing it in sub-second time, rendering that face, playing whatever game that face is in, and all that's got to be done sharing the same sort of processor GPU load, right? But I'm telling you, we're not very far away from it. Our expectation is that this is sort of a this year thing. The real challenge for us, actually, in a lot of what we do is finding partners where we can actually put this into a place where it really works, right? So demos are nice, floating heads of Emily are nice, so go ahead and run this. And the thing to see here is that this is not Emily quality. This is kind of what you saw, sort of GTA 4 quality, but this is the quality we can do live right now, right? So any kind of game level thing you want to do, we can kind of do, right? And so what's my challenge for sort of the next 18 months is around making that drive Emily at that level of photorealism, right? And then there's anything you can do. So where I think we end up, actually, is a place where the technology becomes not the problem anymore, right? You solve the hardware problem, right? You solve the software problem. We'll solve the production problem and the animation problem. And what you get is you're doing storytelling now. It's about the interactive game. It's about directing the movie the way you want to get it done. That's where we were